Okay, so let's continue with the lecture. And so today, the next group of diuretics that I am going to talk about is the potassium-sparing diuretics. Almost all the diuretics that I discuss will lead to loss of what? Potassium. But we have one diuretic that helps the body to conserve what? Potassium. And we call that diuretic the potassium-sparing diuretic. Potassium-sparing diuretic. And often physicians or doctors will add potassium-sparing diuretic to some of the potassium-losing diuretics like furosemide, so that when these combinations are given, we are able to prevent what? Hypokalemia. So sometimes we do those combinations to prevent hypokalemia. All right. So the potassium-sparing diuretics, where are they acting? They act within the principal cells of the collecting tubules. They act within the principal cells of what? The collecting tubules. Or some people will say they act within the collecting tubules. And what are they doing? What is their mechanism of action? If you ask any nursing student or PE student what's the function of aldosterone, they will tell us that when aldosterone is released, it causes the body to retain more sodium. And when we are retaining sodium, we lose what? Potassium. So potassium-sparing diuretics help us to rather retain potassium and lose sodium. So let's see what happens when aldosterone is what? Released. When aldosterone is released. So when aldosterone is released, aldosterone will go and bind to the aldosterone receptors. So when aldosterone is released, so if this is the zonal glomerular cells, and we have maybe the aldosterone released over here. When aldosterone is released, aldosterone will diffuse and go into the cytoplasm of the cell. When aldosterone goes into the cytoplasm of the cell, they bind to aldosterone receptors within the cell. So aldosterone will go and bind to the aldosterone receptors. Most of the time, the aldosterone receptors, they have a binding domain for aldosterone, and they have the DNA domain over there. Most of the time, the DNA domain is inactive. But when aldosterone binds to its aldosterone receptors within the cytoplasm, it activates the DNA domain. So the DNA domain becomes very active. Then the DNA domain will now translocate itself into the nucleus. And when it goes to the nucleus, it causes expression of genetic material or production of genetic material. And one genetic material that's sometimes produced is what we call the messenger RNA. The messenger RNA, mRNA. And this messenger RNA, when this messenger RNA is produced or synthesized, this helps in production of different types of proteins. And one of the proteins that is produced is what we call the aldosterone-induced protein. The aldosterone-induced protein. So one, aldosterone was released. Aldosterone diffused into the cytoplasm, bounded to the aldosterone receptors, and that activated the DNA domain of the receptor. And this DNA domain will translocate itself into the nucleus. And in the nucleus, it will cause the expression of certain genetic materials. Then we are going to produce what we call messenger RNA. And when messenger RNA is produced, messenger RNA will lead to the synthesis of different types of protein. One of the proteins that is produced is what we call aldosterone-induced protein. When aldosterone-induced protein is produced, what do they do? Now let's see what aldosterone-induced proteins are going to do. Let's see what aldosterone-induced proteins are going to do. All right. So let me just extend this cell within the principal cells. So when aldosterone-induced proteins are produced, this is what aldosterone-induced proteins will go and do. One, on the principal cells, on the luminal cells, we have some sodium channels which are mostly inactive. We have sodium channels which are mostly inactive. So the aldosterone-induced protein will go and activate every inactive protein or sodium channel at the luminal side of the distal of the collecting tubules. So over here, this sodium channel that were inactive will be activated by the aldosterone-induced protein. So the first thing that they do is one, they will activate what? The sodium channels. Then the next one is that some of the sodium channels were within the cytoplasm. So what the aldosterone-induced protein will do is that the aldosterone-induced protein will implant the sodium channels on the luminal side. So these sodium channels were already within the cytoplasm. So what the aldosterone-induced protein will do is that it will push this sodium channel to the surface. So this sodium channel will now be implanted at the luminal side. So we are having more sodium channels. The third thing that the aldosterone-induced protein will do is that the aldosterone-induced protein will also synthesize sodium channels. So what are we doing? We are increasing the sodium channels at the luminal side of the principal cells of the collecting tubules. And if you are increasing the sodium channels at the luminal side, then what will happen? Then the sodium that is coming in here can all be taken in. Are you okay? And if the sodium load increases, then the next thing that is also going to happen. So just take note that the aldosterone-induced protein will one, activate inactive sodium channels at the luminal side. They will also help in inserting sodium channels that were in the cytoplasm or the cytosol into the luminal side. Then the third one is that they will help in synthesizing sodium channels. Are you okay? So these three things. Then when it comes to the basolateral membranes, this is what it is going to do. At the basolateral membranes, the aldosterone-induced protein help in the synthesis of sodium, potassium, ATPase pump. So this is what they are doing. They are also increasing the synthesis of the sodium, potassium, ATPase pump at the basolateral membrane. Then two, at the basolateral membranes also, we might have sodium, potassium, ATPase pump which were inactive, and under the influence of the aldosterone-induced protein, those sodium, potassium, ATPase pump which were inactive will become active. And the third step, the sodium, potassium, ATPase pump that were also in the cytoplasm will also be inserted at the basolateral membranes of the principal cells of the collecting tubules. So I've mentioned 6 things over here under the influence of the aldosterone-induced protein. The first thing is that when aldosterone-induced protein is produced, they will activate inactive sodium channels. So the sodium channels which were on the luminal side, which were not active, were activated. So now we have a lot of active sodium channels. The next thing is that the sodium channels which were in the cytoplasm or the cytosol will be inserted at the luminal side of the basolateral, at the luminal side of the collecting tubules of the principal cells. And the third thing is that they are going to synthesize a lot of sodium channels. Then at the basolateral membranes, we are synthesizing sodium, potassium, ATPase pump. We are inserting sodium, potassium, ATPase pump. Then we are activating sodium, potassium, ATPase pump. So this is the function of aldosterone. So if sodium is now coming in, we know that one function of aldosterone is help the body to retain sodium. Are you okay? So when sodium comes in, we have a lot of sodium channels over here. So the sodium can be taken in. Then when the sodium gets into the cell, at the cell we have the sodium potassium pump, where the cell constantly throws sodium into the blood and brings potassium into the cell. So the sodium that is coming here will eventually be pumped back into the blood. So when the sodium goes into the blood, potassium will be brought into the cell. And when the potassium are brought into the cell, because of the high concentration of potassium in the cell, potassium will also leak through the potassium channels. Then we are going to lose potassium. So this is how aldosterone helps the body to retain sodium and for us to lose potassium. Now we are coming to talk about the potassium-sparing diuretics. How are these drugs going to work? Alright, so with the potassium-sparing diuretics, we have 2 forms of the potassium-sparing diuretics. We have 2 forms of the potassium-sparing diuretics. we have one form that affects sodium channels, and we have another form that also affects the aldosterone receptors. So we are going to talk about the two forms of potassium-sparing diuretics at the moment. All right, so let's all pay attention and let's see. So as I said, now we have our sodium channels which are implanted at the luminal side of the principal cells of the collecting tubules. So these sodium channels will constantly take sodium, bring them into the cell, and when sodium enters into the cell, we have this sodium-potassium pump that constantly throw 3 sodium out and bring in 2 potassium. So the cells become poor in sodium and rich in potassium. So with the potassium-sparing diuretics, as I said, we have 2 forms of this drug. We have what we call triamterene, we have amiloride, triamterene and amiloride. This triamterene and amiloride affect sodium channels over here. Then we have the other one we call the spironolactone. This drug is also known as the aldosterone antagonist. So now let's talk about their mechanism of action. Spironolactone only works when aldosterone is present. So they work in the presence of those mineralocorticoids. They work in the presence of aldosterone. When you give this agent, don't forget I said when aldosterone is produced, aldosterone will diffuse into the cytoplasm where they go and bind to their receptors and activate the DNA binding domain. Okay. So that is when the DNA binding domain will translocate into the nucleus and synthesize messenger RNA. And messenger RNA will come and produce different type of protein. And one of the proteins is the aldosterone-induced protein. Alright, so when we give the spironolactone will go and occupy the binding site of aldosterone. So when aldosterone is released and come into the system, that binding site has been blocked. So when the binding site is blocked, we don't activate the DNA binding domain. And if the DNA binding domain is not activated, what do you think will happen? We are not going to synthesize messenger RNA to produce aldosterone-induced protein. And when you don't have aldosterone-induced protein produced, then we are not going to synthesize